Hello everyone. In this video we will see about the operation of half-wave rectifier without filter and with filter. Generally the rectifier means which converts the alternating current source into a direct current source. So to perform a half-wave rectifier we require a step-down transformer and diode and then load resistance. Step-down transformer consists of primary winding and secondary winding. So here the number of turns of primary will be higher than the secondary. So when a primary winding is supplied through an alternating source, the winding gets excited, so the flux is created. The secondary winding experiences an alternating flux because of the primary winding flux. So the induced EMF then flows through the external circuit and then which produces an output here. So here this is the corresponding step down value alternating current source. During the positive off cycle the diode will be get forward bias, so it will produce the output here, and then during negative off cycle the diode gets a reverse bias, so the diode is completely off, there will be no current flow, so the output will be in the zero. And then likewise once again the positive off cycle it will provide the diode gets forward bias, so it produces the output, and then during negative off cycle the diode gets reverse bias, there is no current flow, and then it won't produce an output. So we can do the same operation during using LT spice. Let us see. So go for a new schematic and then take an inductor and then take another inductor for secondary. So use a mirror. I have changed the mirror orientation has been changed and L1 and L2 is placed, and then I need a voltage source for an alternating current source. So get a voltage and then we need a diode and then we need a resistor. So I have changed the orientation of the diode, and then we need a resistor for load resistance, and then I have kept in load resistance. So now we can give the connection. So we have given the connection. So now we can use the ground for both the circuits, and then we should give an AC voltage source. So right click the voltage source and then go to advanced and then select the sign. So the DC offset is 0 and then amplitude is 230 volts and frequency is 50 Hertz and then series resistance is 0.0001. And then since we are using a step down transformer, so the primary winding should be higher than the secondary windings. So here I will consider 10 micro, and secondary windings let us consider as a 1 micro, and then the resistance which we can use it here is an 1 kilo ohm. So usually in LT space point of view there is nothing called step down transformer. So in LT space point of view, this V1 and L1 is one circuit and L2, D1 and R1 is another circuit. So to create a step down transformer in LT space, usually in step down transformer we have a coupling coefficient. The coupling coefficient is nothing but the ratio of mutual inductance between the two coils, between L1 and L2. That is called coupling coefficient. There is a factor is called K. So always K should be from the range of 0 to 1. When K is equal to 0, it is called loosely coupled. When K is equal to 1, it is called tightly coupled. So to create a coupling coefficient between these two circuits, we will use a spice directive. So click here, spice directive, and type K. K is called coupling coefficient. The coupling coefficient we are going to create between the L1 and L2. So type L1, L2, And what is the coupling coefficient value? The coupling coefficient value is 1. K is equal to 1. When K is equal to 1, it is called tightly coupled. So you can see here the both our coupling coefficient has been done. So now we can go for an simulation. And stop time is 1 second and maximum time step is 0.001. So now we can go for simulation. So I need to see three inputs. So this is the corresponding input. This is the corresponding input voltage, AC voltage. So you can see here it goes maximum of 230 volts. So it will be stepped down because of primary winding, secondary winding. So here you can see the secondary, because of secondary windings, the maximum voltage is around 72 volts. And then we can see the corresponding output during the load resistance. So we can see here during the positive off cycle, let me zoom into one part. You can see here during positive off cycle it is conducting, so it produces the output, and then during negative off cycle the diode is reverse bias, so it is completely gets cut off, and positive off cycle once again conducting, in negative off cycle diode is reverse bias, so it's completely switched off. So this is called an half-wave rectifier without filter. So the with filter is nothing but how about adding in capacitance? How about adding in capacitance in the output side? So by adding a capacitance, RC filter, by adding in capacitance, so whenever the diode gets forward bias, the capacitor gets charged up. You can see here the capacitor is getting charging, and whenever the diode gets reverse bias, the capacitor will discharge the current whatever it's stored. Because ultimately the rectifier means we require an DC voltage as an output side. So here we have got an pulsating DC. So what happens, keep on only for positive off cycle it is producing and negative off cycle it is not producing. So since we want more DC voltage, we are going to add a capacitance in the along with the resistance. So let me add a capacitance here. And then give the capacitance value as 100 microfarad. So now we can see the output here. We will zoom the one part. So you can see here the capacitor is charging, and then when the diode is reverse bias it is discharged. Once again when the diode is forward bias, charging and discharging, charging, discharging. So moreover here compared to the previous output without filter, it produces an pulsating DC. It's almost DC. So since it is charging, discharging, it is called pulsating DC. So this is how we can use the half rectifier for converting the AC to DC and with filter and without filter. Thank you for watching.